we will continue the same exercise 2.4 from the chapter applications of derivatives, which is based on the maxima and minima. How to find the maximum and minimum values of the function. In that, the 12th example we will see today. A wire of length 36 meter is bent to form a rectangle. Find its dimensions if the area of the rectangle is maximum. From this wire of 36 meter, we have to form the rectangle. So let x meter and y meter be the length and breadth of the rectangle. So what is the perimeter? Then perimeter is the 2x plus 2y. Perimeter means sum of all sides of the rectangle. It is given to be 36, okay, because the rectangle is formed from the wire of 36 meter. So 36 is equal to 2 times x plus y, which gives x plus y is 18. So y is equal to 18 minus x. Now, what is the formula to find the area of the rectangle? It is x into y. So length into breadth gives the area of the rectangle. So x into 18 minus x is the area of the rectangle. Take multiplication, simplify it. This is our equation number 1. Now take the derivative of this function. The derivative of this function is f dash of x is 18 minus 2x. Again differentiate it so that we obtain the second order derivative. F double dash of x, it is minus 2. Now we know that for extreme values, that means for maximum, either maximum or minimum, f dash of x must be equal to 0. So from this equation 2, we get 18 minus 2x is 0, which implies x is equal to 9. This is the stationary point or the turning point. Now we will check the sign of the second derivative at this point, but already the second derivative is minus 2, that means it is negative. So whatever the stationary point we have obtained, at that point the function will have maxima. By second derivative test, f is maximum at x is equal to 9. So what will be the other value of y? Y is 18 minus x. So put x is equal to 9, you get 18 minus 9 is 9. So the area of the rectangle is maximum when the length is equal to 9, breadth is equal to 9. That means it is clear that the area of the rectangle is maximum if and only if it is a square. Okay, length is 9, breadth is 9. That means it is a square. The 13th example is a ball is thrown in the air. Its height at any time t is given by h is equal to 3 plus 14t minus 5t square. Find the maximum height it can reach. Okay, this is the equation of height is given. Differentiating with respect to t, we get 14 minus 10t. Now for maximum value, we know that dh by dt is 0. That is, the first derivative is 0. So using that condition, we obtain t is equal to 1.4 second. Now again differentiate this function with respect to t. We get d2h by dt square is minus 10. Now it is a negative, so second order derivative is less than 0. So the stationary point we have obtained t is equal to 1.4. At this point we will get the maximum value of this given function. So the maximum value at t is equal to 1.4 will be obtained by putting t is equal to 1.4 in the given function. So put t is equal to 1.4 and simplify it. You will reach to the step 3 plus 9.8, that is 12.8 units. Okay. Now there is no any unit is given for the height. So you are using the units. So the maximum height will be attained by the ball is 12.8. Again, I have written here meter, but actually it is not given. The unit is not given, so I have to use units only. 12.8 units. This is the correction. 12.8 units. Now moving further to the next example. Find the largest size of the rectangle. Okay, find the largest size of the rectangle that can be inscribed in a semicircle of radius 1 unit so that two vertices lie on the diameter. Suppose this is the rectangle. Let A, B, C, D be the rectangle. It is inscribed in a semicircle. It is a semicircle whose radius is 1 unit. And if you see, the two vertices of that rectangle lies on the diameter. So here AB is the same as DC is the length of the rectangle. Let it be X, and BC and AD be the breadth of the rectangle. Now as O be the center of this semicircle, OD is equal to 1 because it is given that the radius of the circle is 1 unit. Now in the triangle DAO and OBC, OAD and OBC by HL test, this OA is equal to OB. OA is equal to 1 upon 2 times AB. That means 1 upon 2 times X. So in right angled triangle OBC, this OB square plus BC square is equal to OC square using Pythagoras theorem. So x by 2 bracket square plus y square must be equal to 1 square. So y square is equal to 1 minus x square by 4, that is 4 minus x square upon 4. So take the square root, y is equal to 1 upon 2 root 4 minus x square. Now I have not taken the plus minus sign here because the breadth is always positive. So we can exclude that negative. So we have taken the only positive value 1 upon 2 root 4 minus x square. Now what is the area of the rectangle? We know that the area of the rectangle is length into breadth. So x into y. But what is y? Y is 1 upon 2 root 4 minus x square. So this is the function which we have to optimize. So take its derivative, differentiating this function with respect to x. Now 1/2 is a constant, so we can keep it as it is. Now here you have to use the product rule. The first function as it is, derivative of the second function plus second function as it is, derivative of the first function. Now here you have to use root of f of x. Its derivative is 1 upon 2 root f of x into f dash of x. So 4 minus x square derivative is minus 2x. So f dash of x is 1 upon 2 times 4 minus x square minus x square. So upon root 4 minus x square. So therefore the first derivative is 2 minus x square upon root 4 minus x square. This is our equation number 2. Now for extreme values, we know that the first derivative must be equal to 0. So 2 minus x square upon root 4 minus x square must be equal to 0. So we get x square is equal to 2. So x is equal to root 2. Again, I have not taken the negative because the length is always positive. Now again differentiate that equation 2 with respect to x. So we obtain the second order derivative. Here you have to use the quotient rule. How to use the quotient rule? So denominator square, denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator. Or one can adjust this denominator in numerator, and then we have to use only derivative of 1 upon v minus 1 upon v square into dv by dx. Okay. So here this root of 4 minus x square. So root f of x, its derivative is 1 upon 2 root f of x into f dash of x. So this is the derivative, and minus 2 times this f of x raised to n is n times f of x raised to n minus 1 into f dash of x. Use that formula, you will obtain this function. So that second order derivative is x cube minus 6x upon 4 minus x square raised to 3 by 2. This is our equation number 3. Now we will check the sign of this second order derivative at x is equal to root 2. So put x is equal to root 2 cube minus 6 times root 2 upon 4 minus root 2 square raised to 3 by 2. So the value is minus 2, which is less than 0. So as the second order derivative is less than 0, by using second derivative test, it is clearly, we can say that f has a minimum value at root 2. By second derivative test, f has maximum and not minimum. Maximum at x is equal to root 2 because second derivative is less than 0. Whenever second derivative is less than 0, function is having maximum value. Second derivative is positive, function has minimum value. So for a, when x is equal to root 2, we have to find the value of y. So what is the y? Y is equal to 1 upon 2 root 4 minus x square. So put x is equal to root 2 here and simplify. You get y is equal to 1 upon root 2. So x is equal to root 2 and y is equal to 1 upon root 2. Okay. So these are the length and breadth of that particular rectangle. Hence, the rectangle has largest size when the length is root 2 units and the breadth is 1 upon root 2 units. So this is the solution of this example. Now, the next example is an open cylindrical tank whose base is a circle is to be constructed of a metal sheet so as to contain the volume of pi a cubic centimeter of water. Find the dimensions so that the sheets is required is minimum. Suppose let x be the radius of the base and h be the height. So what is the volume of the cylinder? It is pi a cube. Now given that S is the surface area of the cylindrical tank, so here the volume of the cylindrical tank is pi x square h and the surface of the cylindrical tank is 2 pi x h upon plus pi x square. Let us see by diagram. This is the circular, no, it is not, it not look like a circular path. So this is the circular part, this is the height of that particular cylinder, and from the top it is open and the radius is x. This is the radius. So what is the area of this base? It is pi x square. And this height, what is the height? The height of the cylinder is h. So the volume is given by pi x square into this h. Now the surface area, then the surface area contains this curved surface area and the base surface area. Base surface area means area of the circle. It is pi x square. Okay, so it is counted, and this curved surface area is 2 pi xh. Okay, 2 pi xh. How? If we cut this cylinder, we get a rectangular sheet whose length is 2 pi x, the circumference of the circle. And what is the length? It is breadth is h. So 2 pi x h is the area of the, so the 2, this is 2 pi x h, 2 pi x h, and this base area pi r square, that is pi x square. So that it is given that pi x square h is pi a cube. So what is h? H is a cube upon x square. This is equation number 1. Now what we will do, we will again the surface area is also given a 2 pi x a cube upon x square plus pi x square. So x is equal to 2 pi e cube upon x, because one x is cancelled, plus pi x square, equation number 2. Now what we want, find the dimension so that the sheet required is minimum. Now sheet required is minimum means we want minimum surface area. So we have to differentiate the surface area with respect to x. So ds by dx is equal to 2 minus 2 pi a cube upon x square plus 2 pi x. Now to have the extreme values, the first derivative must be equal to 0. So minus 2 pi a cube upon x square plus 2 pi x is equal to 0. Okay. So simplifying it, you get x is equal to a, the stationary point. Okay. Now the second derivative of this surface area is we have to obtain. It comes 4 pi a cube upon x cube plus 2 pi. Now we will check the sign of this second derivative when x is equal to a, and it comes 6 pi. That means positive. Whenever the second derivative is positive, by second derivative test, it is clearly that given that the point x is equal to a, the surface area will be minimum. So at x is equal to a, what is the height of that cylinder? A cube upon a square, that is a. The height of the cylinder is a. Hence, the metal sheet is minimum when radius is equal to height is equal to a centimeter. Okay, so this is the solution. The perimeter of triangle is 10. That means sum of the three sides of the triangle is 10 centimeter. If one of the side is 4 centimeter, what are the other two sides of the triangle for its maximum area? Now one side of the triangle is given 4 centimeter. Let the other two sides be x and y. So the perimeter is x plus y plus 4, but it is given that 10. So x plus y is 6. So y is equal to 6 minus x. So the three sides are x, 6 minus x, and 4. Now what is the area of the triangle? This is the hero's formula to find the area of the triangle, where s is the half perimeter, a plus b plus c upon 2, where a plus b plus c are the a, b, c are the sides of the triangle. So what is this? S is x plus 6 minus x plus 4. So you get 5. Perimeter, half perimeter of the triangle is 5. So area of the triangle is root 5 times 5 minus x, 5 minus 6 plus x, 5 minus 4. So 5 times 5 minus x, 5 x minus 1 and into 1. So 30x minus 25 minus 5x square. So after simplifying, you get the function of the area. So take f of x is equal to root 30x minus 25 minus 5x square. We will differentiate this function with respect to x. Root of f of x is 1 upon 2 root f of x into f dash of x. Now, for extreme values, the first derivative must be equal to 0. So, equate it to 0, you get 30 minus 10x is 0. That means x is equal to 30. Now, to have to check the second order derivative, we must have the second order derivative. So, we have to find out the second order derivative from this first order derivative. So differentiate this first order derivative with respect to x. F double dash of x is equal to, here we use quotient rule, square of the denominator, then denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator. So once you simplify it, you will get the derivative of this function, minus 100 upon 30x minus 25 minus 5x square raised to 3 by 2. This is our equation number 5th. So we will put x is equal to 3 in this second order derivative, and we'll check the sign of this function. Okay. So after putting the x is equal to 3, we reach to the step f double dash at 3 is less than 0. That means the second order derivative is negative. So the function must have maximum at x is equal to 3 by using second derivative test. Okay, so x is equal to 3 implies what will be the y? Y means 6 minus 3 is 3. So the first side is 3, other side is 3, and the given one of the side is 4. So what are the two remaining sides then? 3 centimeter and 3 centimeter. These are the three sides. So that the triangle is of its maximum area. If we take these sides 3 centimeter, 3 centimeter and 4, that means it will have the maximum area. A box with a square base is to have an open top. The surface area of the box is 192 square centimeter. What should be its dimensions in order that the volume is largest? This is the box. X be the base length of the side of the square at the base, and y be the height of the box. So what is the surface area then? Surface area, the top surface is open, so the bottom is having surface x square, and this is one surface whose area is xy. This is another surface, his area is xy. This is another surface, that area is xy, and this is the backside area, is surface having the area x into y. So there are 1, 2, 3 and 4 surfaces. So 4 times xy. So it is given that 192 square centimeter. So it is given. So y is 192 minus x square upon 4x is the function of x. So the volume V, what is the volume of this open box? So the base area into height. So base area is x into x is x square into height is y. So x square y is the volume of the box. So simplify, put that value of y, whatever we obtained here, put it in this equation and simplify it. We will take this v, f of x. F of x is 192x minus x cube upon 4, and we will differentiate this function with respect to x. So 1 upon 4 is a constant, so we can keep outside. Derivative of 192x is 192. Derivative of x cube is 3x square. Okay. Now for extreme values, this first derivative must be equal to 0. So put it equal to 0. Simplify, you will get x is equal to 8, because x is the length of the square. It is not negative. So the stationary point is x is equal to 8. Now differentiating this equation 3, so that we obtain the second order derivative. It is minus 3x upon 2. So it is the second order derivative at x is equal to 8 is minus 12, so less than 0. So the function will have maximum value at x is equal to 8. So by second derivative test, f has maximum at x is equal to 8. So what will be the y? So to find the value of y, the height of the box, we will put x is equal to 8 in equation number 1. So 192 minus 8 square upon 4 times 8. So 128 upon 32, that is 4. So hence the volume of the box is maximum when the side of the square base is 8 centimeter and the height is 4 centimeter. If we choose these dimensions to form the open box, then there will be a maximum volume. Okay, so we will stop here. In next lecture, we will again continue the same exercise.